Hey, welcome back to this video series where we are learning how to integrate AI products into web development applications using tools like OpenAI and Qwik.js. If you missed the first video in the series, I would recommend you check that out because that is where we bootstrapped the application and got all of our prerequisites in order. It's boring, but it's important. In this video, we are going to learn how to incorporate some AI toolings using Fetch to make API requests to OpenAI's API endpoints, and we're going to learn how to integrate that into Qwik.js and how to make sure that we're not leaking private keys. Hopefully by the end of this video, we will have a rudimentary but working AI application. Before we actually get into building anything today, we're going to have to head over to platform.openai.com. This is assuming you already have your account set up. And when you set up a new account, you should have been given some credits to use their services. So we can come to your API keys page and you can generate a new secret key. I'm going to call mine versus app. Which is fine. It's fine if you see this because I'll probably have this deleted by the time the video is out, but I want to show you how everything works. So make sure that you copy this this string somewhere and definitely don't lose it because this is the only time you're going to get a chance to see it. And once you close this, can't see it anymore. So I'm actually just going to go back to my code and for the time being, paste it there so that I definitely have it somewhere. Once we have our API keys, I also want to show this API reference, which shows us that there is a node module available on NPM, but we're not going to be using that because there's actually some issues that I ran into with it. And also I want to show things at a fundamental level so that you know everything that's going on that this library would be doing anyway. We also have to take note that you will need to make an authorization, or for authenticated requests, you'll have to include the authorization header set to bearer and then your open API key, something like this. And as far as discovering which API routes are available, I encourage you to check out this reference where we can go to something like chat and see exactly where the API endpoints are, and even a helpful example. Now, it's worth pointing out that this example includes the API endpoint, that there is the content type header set to application JSON. There is the authorization header set to bearer and then your Open API or OpenAI API key, and the data you want to send as a JSON string. Now, inside of that data, there's two things. There is the model and the messages. The model is going to, in this case, be GPT 3.5 Turbo, and the messages is an array that includes an object that sets the role to system and then sets the content to whatever message you want to send to the system. And another object that includes the role from the user, and this content represents the prompt that you actually want to send to the system as the user. Hopefully that makes sense. But I'll assume that the next question that you may be having is, well, what the heck is a model and how do I know which one to use? And the answer comes from the documentation where you can scroll down to this models page and it has a list of all of the different available models, including the subsets for each individual model, which just represents their fine-tuned to do slightly different things based on different training data. They have different costs and different capabilities. So it's good to know that these are available. In our case, we'll be sticking to using GPT 3.5 Turbo. For this series, it's not going to be a very big difference which model you use. So this is just a good general purpose model. So to make our very first HTTP request, I'm actually going to do this just in the console here. And I'm going to be using fetch. So we're going to say fetch. We're going to go to the API endpoint that we discussed, which was the chat completions endpoint. And we're going to pass an options object to this fetch API. First, we know that we have to set the method to post, has to be a post request. So we're going to say method is post. Next, we had to pass in some custom headers. So we can do the headers property to an object. And we know we have to set the content type. I don't think it matters that it's uppercase or lowercase, but content type should be application/JSON. And we have to set the authorization header to bearer space and then our token. Now I copy and pasted my token there. So I'm going to grab that and whoops, put that in there, comma. Then we can close the headers, and we have to send a body on the request, which we said is going to be a JSON string. So I'm going to say json.stringify, whoops, stringify, thank you. And we're going to pass in an object. This object needs to have a property of model where we tell it which model we want to use. As we agreed, we said GPT-3.5 dash turbo. And then we have to give it the messages. So messages is going to be an array containing an object, and that object must have a role. And in our case, we're just going to be telling the platform that the user is making a request, and the request is going to have some content, and that content is going to be something like, tell me a joke. We can close the object, we can close the array of messages, we can close the object of JSON data and close that JSON stringify. And then we can close our fetch options, and then we can close off the fetch request and make that request. And that's going to kick off a promise. We can explore the network tab, see the completions, and see that we got something back containing a bunch of data, including this property called choices, which is an array that has some information here, including a message with the content and the role of assistant. And the content is, why don't scientists trust atoms? Because they make up everything. Very clever. Okay, so that's all fine and dandy. We got it working. So I'm going to take this and copy it as a prototype and just bring this into my application now. And over here, I probably don't need this anymore. I know that I need to make this API request somehow. And I also know that I'm going to be wanting to send some sort of payload that is probably dynamic, ideally something that the user is going to submit. So in order to take user submitted content and making an HTTP request, that tells me I probably would be well off to use a form. So we'll take this, just kind of put that on hold for now, and then we'll start building the UI that's going to integrate with this HTTP request. So we'll start with a form. We'll leave the action off for now. We're going to want some sort of input, and if we want an input, we need a label, HTML4. Qwik uses JSX, but it has a different compiler that actually will use the standard HTML attributes. So we can say this, I'm going to call this prompt. Label, we can say is prompt. And then I'll need some sort of input. In this case, I think a text area makes sense. We're going to give it a name of prompt and an ID of prompt. We don't care about the columns and rows. That's fine. And then this form also needs a button, and we're just going to say submit. And this will have a type equal to submit. Not necessary, but I like to be explicit about that. Okay, so let's just tackle this with the most sort of naive approach, and that's going to be to add a submit on submit handler with a $sign. Notice that it's going to be important for later. We're going to pass in an event handler, so we'll take a function that takes an event and then does something with that event. So we're going to call event.prevent default, sure, and that is going to prevent the default behavior of a form, which is to essentially make the HTTP request, but in doing so, submit that page or reload that page. And instead what we can do is just kind of take this out of here and paste it in here, and there we go. Oh, didn't get my auto formatting set up. Oops. There. And there we go. So let's see what happens when we go and try to submit this form. When we click it, you'll notice that, well, we got some layout shift for some reason, but more importantly, you'll notice that the page refreshes, and I would expect that not to happen because we are calling this event.prevent default. But if you notice the little red squiggly line, you'll see that prevent default does not actually exist on the type of a quick submit event, which is slightly different than an HTML submit event. And if you want to learn more about it, I would encourage going to the Qwik docs because this is kind of a critical thing specific to this framework. The reason this doesn't work is because Qwik has this optimizer tool that's basically used to lazy load your event handlers, which means the code for these event handlers are only ever executed on demand when they're needed, and that is a performance improvement. However, this comes at the cost of not being able to do things inline as you would expect and have access to the actual submit event right away. Now that does mean that this event.prevent default will not actually work, but the Qwik team does provide a way of tapping into the actual events and calling things like prevent default on submit. So we don't need this, and now we should be able to see this work in action. So close this, and we submit this event now. We can see the page did not refresh, and we are able to go over to the network tab and see that the same request is being sent. Great. Now, the next thing I want to do is actually just make this fetch request actually work with the text area that we have here. So I basically need to swap in the content here with the dynamic content from the text area. I'm going to make this a little bit easier for me so I don't have to type it in every time and just have it ready to go or have the text area pre-filled with that. And then we essentially need to place in the actual text area value here. So I can grab the form DOM node from const form equals event dot target, and then I can say const form data is going to equal new form data on that form target, and then we can say that the const prompt is going to equal form data.get, and we'll grab the prompt which corresponds to the name of the input. So once we have that, we can put that in the body here. I think what I'll actually do is take this out and we'll call that the body, and we'll say const body equals these values, and I'm pretty happy with that. Okay, let's see if we just have this naive approach sort of working. We submit, we get the API request, we get the response. Excellent. Now, there's just one kind of big problem with this approach so far, and if you have been building applications, you may be aware of it, and that is that if we ship this application as it is right now, anyone with just a little bit of tech savviness can open up their dev tools, open the network tab, and look at the headers for the requests that are being sent, and they can examine some of these headers, including the request headers that include the authorization header with the API key, which means if someone wanted to, they could grab this API key and start making API requests to OpenAI on our behalf, which is a problem because that means that they would be using some of our resources and could end up costing us money. So what we really want to do is hide this information by putting it behind some sort of proxy server on our end, or a backend in our case, and have the client, have the front end send a request to the backend, and have the backend make the API request to OpenAI, and then just respond with the answer. Okay, so the question is, how do we move this functionality into the backend, or how do we integrate some sort of backend service in Qwik? And the answer is actually quite nice, because if you go to qwik.builder.io, that's where we get into a little bit of the difference between Qwik as a front-end JavaScript framework and their meta framework, QwikCity, which is the full stack front and back end server-side rendered support of Qwik. And we can get into a number of different ways to create back-end processing or compute services, but one of my favorite ones is with actions. So what actions allow you to do is, in the same file that you define your component, you can actually define some logic that is only going to run on the server, but then which will provide that functionality to the front end via a methodology called RPC, or remote procedure call, where essentially the front end has, or one computer, like the front end, has the ability to execute a function or a procedure on a remote computer, such as the backend. So in our code, what we'll do is come here and we have to export this, but we'll say export const, use prompt action is what I'll call it. And that's going to equal some sort of action, $, yeah, the route action. And inside of that, we're going to pass in a callback function. So for now, I'm just going to say console log action, and then we will return some sort of data. I'm going to return an object with O set to K. Okay. Now, what this provides us is a hook that we can use inside of our component. And what this is going to return is the actual action. So const action is going to equal use prompt action. And then let's just see what this looks like in the client. So I'm going to say json.stringify the action, and that should be good enough. Now, the other interesting thing is we can actually take this action and kind of submit it. So let me put this stuff on pause. But we are going to trigger it by calling action.submit. So when this form is submitted, we'll execute action.submit and see what happens. So here we can see the action path has this QAction parameter, and it tells us if it's running is false. We're going to submit it. And we see for a very brief second, we saw that is running was true. And then we get a status code that comes back, which is 200, which corresponds to the status code of the HTTP request. And we get the value of OK, which is the value that we returned. Now, this is very handy if you want to create some sort of front end that keeps track of not just sending the request, but it's doing all the work of tracking whether it's running or not, the status code, and getting the value for you, which would be great on its own, except that Qwik actually does a lot of work for us with these actions by providing a form component that integrates with it perfectly. So, oops, I want to grab a form. What is it? A form. Where is it? There we go. I want to grab the form component. So we're importing that from QwikCity. We also imported the route action from QwikCity. And I think I'm actually going to get rid of this document head because I don't think I really need it. And I'm just going to get rid of this stuff. Don't need that. But we'll have this form, and that will close off. And if we replace this form with this other one, so we can go ahead and copy all of this, burp, paste it right there, space for the action. And then we'll just move this down. We'll get rid of this form here. We'll replace this one with the closing tag. We can ignore all this for now. And I'm actually going to just, well, I'm going to remove this stuff and move it in here as a commented block. And then I'm going to get rid of this on submit, clean it up. We can get rid of the prevent default. And then all we need to do is provide the actual action, which doesn't correspond quite with the native HTML action because that expects a string. And this expects a action store, which is what we get back here. So we'll place that there. And that's what that should look like. Now, if we go to our front end, we can see if we submit this, we still get the same behavior of updating, and we have a lot less code that we actually had to write. So this is very nice because now we can take this action and do things like say, well, how about the ARIA disabled? We might want to give some hint that it might want to be disabled if the action is running. We might want to do something like say, if the action is running, then we can write some text that says, oops, submitting, ... Otherwise, just submit. Oh, and that should actually be a question mark. There we go. That looks more like it. So we come back here. We see for a brief moment there, it was submitting until it completed. And that has simplified the whole interface about submitting a form just on the client side and keeping track of the state of that submission. So now the goal is to execute this information on the back end. We'll notice that in the network tab, we are not seeing anything logged to the console, but on the server side, we are seeing those logs. So we've confirmed that using this action is going to execute this code only on the server, and it's going to return whatever value it had here. So that means that we can grab this information and replace it, or essentially bring back this fetch call. So I'm going to say that this route action is actually going to be an async function. And we're going to say const response is going to be await on this fetch request. Then we essentially need to get this prompt, which we actually get from the body of this request. So form data is whatever this function or this action is called with. Because this action is submitted on a form component, it's going to pass the form data to the actions submit function, which we saw earlier, which means we're going to have access to it. So we no longer need the event target because that's not accessible on the back end. We no longer need to construct this form data because we won't have access to the form, but we will have access to this form data via the HTTP request. And once we've got here, we have our form data, we are setting up the prompt, we are sending the request, we're doing something with the response. We need to say console log data, and I'm just going to say that the const data is equal to await response.json. See about that. All right, we go back to our front end, we submit this, we explore the console. Oh, right, and this is going to be an issue, is that this actually is not a form data object. This is going to take the serialized data that's sent with the submission request and actually turn it into an object itself. So a little bit of change there. It shouldn't be get, this should be just prompt. And once again, this is coming from the form data, which sets up that property based on the input called name. So whatever we change this to, if it was promptee or something like that, then the property here would be promptee. Don't want to do that though. So I believe that should be the object containing the form data, and we are grabbing the prompt off of it. Let me try this one more time without looking. And we got something. Okay, that request went off. It took a bit longer this time. And then when we get the response back, we see that we have an object in the server-side log that has the ID, when it was created, which model it uses, and once again, the choices as an array containing the message. So let's get into that message and see what we've got there. So instead of grabbing the data, we're going to grab data.choices, grab the first index in the array, and what was it? Message, I think. Let's see what this is. Burp, burp, burp. Okay, that's right. It's an object that has the role of assistant. That is essentially the AI quote unquote assistant who is presenting this content. And it's really the content that we're interested in. So just as a response, we can take this message and grab the content off of it. And now we can actually just return something like that. So we no longer need that. Let's see what we've got just here. Setting it up, we've gone from a naive solution to something a little bit nicer. Also, I'm going to go ahead and get rid of this. Burp, burp. And let's see, let's submit this. We see that it's submitting, and then we got a response. And in the network, we see the response is this weird thing. So what is going on here? And this is very important to understand. We do see in there the answer that we're working with, but there's also all of this other information. And this is something that has to do specifically with Qwik's optimizer. So we touched on it briefly, but essentially what Qwik is doing here is when you define a route action, in addition to a couple of other functions they provide that end with a $, this $, is a hint to the optimizer that is saying, hey, we're gonna do some sort of compilation that takes this code and modifies it. So as developers that are authoring this code, we see just a function that is going to be run on the back end. But what Qwik has to do is somehow turn that into computer code that can say, when we have this form needs to submit this action at this URL. And the logic that needs to submit this form on the client side is going to exist here. So Qwik is going to essentially lazy load that event handler, bring it back to the front end, use that to create the HTTP request that's then going to execute the RPC code that's going to ultimately call this function. And when this function comes back, it needs to provide some data that then Qwik needs to figure out how to put back into the client-side application. And it does all of this through some sort of serialization of the data that comes back, so that we have the payload of what we sent, but then Qwik's sort of client-side library is also going to know what to do with all of this information as well. Okay, so that's super handy. We can see that on these requests, the key thing that we were worried about is not sending our secret API keys with the request. And we can see in the request headers, we no longer have the authorization header, and we're no longer sending that token. So no one that's exploring this is going to be able to sort of steal the token from us. However, we do still have a little bit of an issue on the backside, because it's generally a bad idea to keep authorization tokens hard-coded into your code. And that's because you may have different people working on your application that may not need the privileged information of being able to authenticate on your behalf. So what we want to do is kind of obfuscate this. I'm going to turn this into backticks, and I'm going to place a variable in here instead called OpenAI underscore API key. And now we need to figure out where this is coming from. And a common practice for building applications like this is to provide these sort of secrets in environment variables. That way, depending on the environment, the variable will be different. So someone that's working in a development environment may have access to a development key, and the staging environment may have a different API key, and a testing environment and the production environment may all have different keys with different privileges, and only the people that have access to those environments may have access to those keys. So the question is, how do we deal with environment variables? Well, in a lot of projects, you might be familiar with this concept of environment variables and .env files, and that's a very common practice in Node ecosystems. However, Qwik is built slightly different. It attempts to be slightly more agnostic about what the runtime is. So for example, Node is just one specific runtime that Qwik might be living in, and .env files are pretty specific to Node, but you may also want to run your application in Bun or Dino or some sort of edge worker. And this standard is not quite consistent across all of the environments. So what does Qwik do? Well, it allows you to access some sort of context in your route actions to the request event. And on this request event object, you can actually grab a method called requestEvent.env.get, and you can pass in the environment variable you want to grab. So I called mine OpenAI underscore API underscore key, which we haven't defined yet, but then we can say const open AI underscore API underscore key is going to equal the environment variable value for this environment variable, right? So that gets pulled out of the environment, it gets assigned here, and then we use it there. The only question is, how do we actually set this in the environment? That's going to depend on the environment in which this is running. In production, that's going to look very different. But in development, what we can do is create a .env.local file that is used to inject environment variables in the local environment. So we can say OpenAI underscore API underscore key is going to equal, and I like to use quotes, although you don't need them, but every environment variable is interpreted as a string regardless, even if you put in a number. So I like to explicitly add the quotes just to make it obvious. Okay, that should have solved that. I'm going to stop my dev server and just restart it, because sometimes you need to do that to make sure the environment variables are injected. And then let's see what we've got. Let's see, before we actually run this code, I'm just going to return it. Return OpenAI API key, that should work. And we will submit this, we'll check the network, we'll get the response. And sure enough, there it is, the first value. That is my OpenAI API key. See? Great. Cool, we got it working. We are doing it responsibly. We're not leaking any secret information. And we're taking advantage of some nice features that Qwik has, despite the fact that we did it from scratch a moment ago. So hopefully it's given us a little bit of appreciation. Now I'm just going to do a little bit of cleanup for styling. I'm going to say class is going to be grid here with a gap of 4. Oh, whoops, wrong element, not there, on the form. And then because I want to put some space in between these, but that means that we kind of have to put a div around that. And then I think that means that this button is going to look kind of funky. Yeah, it's going to be all stretched out. So what we'll do is also put a div around that. Okay, now there is just one thing that I need to add, and that is actually making this work. So it tells us a joke, but it doesn't currently do anything. So let's get that response onto the page. And this is, once again, a really nice thing about this action and form thing that I will highlight in Qwik. If we didn't have access to that, we might have to do some sort of state management that makes, after the fetch request, we make that HTTP request, it comes back, we update the state, and somehow either write that content to the page or update some reactive state. But because we have this action all wrapped up in one thing and it provides us with that information, we can actually show that on the page. So I might do something like say, if the action dot value, and then do some conditional logic to add, let's say, an article tag, inside of which maybe we'll have a paragraph that contains the action dot value. And I'm just going to add a little bit of styles here. I'll say class. We're going to have something with the margin top so it's not right up against that button. I'm going to give it a border. I'm going to add a little bit more of a wider border and make that border rounded. And then we'll add some padding inside of that and give it a background color. And Tailwind inherently doesn't have access to this, so I'm going to use a dynamic value to set the background color to the canvas keyword. So if I did that all right, we can submit this, and then when it comes back, hey, there we go, look at that. Didn't quite get the background color because I totally spelled that wrong. Let's see, background, there you go. Canvas is not a keyword, canvas is. Okay, let's see, we submit it, we're submitting, we wait, and then it comes back, and there you go. Sure, here's a joke for you. Why don't scientists trust atoms? Because they make up everything. All right, how about that? We have successfully built an application that uses AI to tell mediocre jokes. The important thing is that we are building the foundations to actually create a much more robust and interesting application. Now, the problem with this one so far is that we are sending the request and we are getting an AI response, but we are waiting for the entirety of the body of that response to be generated. And we could actually improve the user experience by having some faster response and seeing that sort of teletype behavior that you may be familiar with if you used an AI chat application in the past. So we're going to build that out in the next video using HTTP streams, which are fascinating and powerful, but also can be kind of confusing. So I'm going to dedicate an entire video just to that. If you want to be notified when that video comes out, be sure to hit that subscribe button. And if you have any comments or questions or concerns, feel free to throw them in the comment section below or find me online somewhere else, and I'll be happy to try and answer them for you. In the meantime, I hope you're having fun and I hope you get to play around with some silly jokes, and I will catch you in the next one.